Okay, so here is our next lesson, and this is a very important one, especially if you're planning on taking calculus next year. Okay, so pre-calc inverse trig functions. So we studied inverse functions early in the semester, and with trig functions, we also have inverses, but we have to restrict the functions to certain values along the unit circle in order for them to have inverses. Okay, so before we go and talk about inverse trig, let's recall what an inverse function is. Okay, there's a couple of different ways that we recognize an inverse function. So first of all, with notation, I'll recognize that something is an inverse function because it's going to have that -1 notation okay, after the f. So this says f inverse of x, not f to the -1. Remember, this is not an exponent, okay? On a graph, there's two ways that I can see that something is an inverse function, okay? So the first thing would be that I have reflection across the line, y equals x, okay? Or my graph is going to pass the horizontal line test, okay? So if I perform the horizontal line test on the original function, then that tells me that that function is invertible, okay? Or if I take the original function and reflect it across the line y equals x and it still passes the vertical line test, then it is a function, an inverse. It has an inverse, excuse me. Okay, in an equation, y and x are going to switch. Okay, so y is equal to x, and if I switch x and y, then that would help me solve for the inverse equation. Okay, so here's an example, just to refresh your memory. If I look at the function f of x equals x cubed, okay, and I graph x cubed, we know is going to be a cubic curve, okay. If I reflect that graph across the line y equals x, then my graph is going to look like this, okay. So if I go to the original function passes the horizontal line test, which tells me that when I invert it, this function is going to pass the vertical line test, okay. I would write the equation of the inverse by taking the original equation, switching x and y, and then resolving for y. So here I would take the cubed root of both sides. So I'd get the cubed root of x is equal to y, but because this is an inverse, I would write this as f inverse of x equals the cubed root of x. So this would be the equation of my inverse using inverse notation. Okay, so let's talk about sine of x. Okay, so in order to understand how an inverse trig function works, we need to look at the entire function of sine from -2 pi to 2 pi. Okay, so remember when we're going around the unit circle, what we want to keep in mind is sine is the y values, okay, of all of these points. And so we want to hit those major 4 as we go around. So remember 0, pi over 2, pi, 3 pi over 2, 2 pi, okay? So if I'm at 0, sine of 0 is 0. So sine starts at 0, okay? This is going to be pi over 2 because this is pi. Sine of pi over 2 is 1. Sine of pi is 0 because then I'm back here, okay? Sine of 3 pi over 2 is going to be -1. And sine of 2 pi is going to be 0, okay? So remember that I can continue this pattern in the opposite direction as well, okay? So this is going to mean me back down at -1, 0, +1, and then 0, okay? So I'm going to connect this curve together. And so what I've just graphed is 2 periods of sine, okay? But one's on the negative axis and one's on the positive. Okay, so now if I ask you, what is the domain of sine of x? Well, the domain of sine of x we know is from -infinity to +infinity because the graph can go on forever. However, I have to look at this in terms of an inverse function, okay? So if I asked you, does sine of x have an inverse? The answer would be no, okay? Because if I draw a horizontal line through this part of the graph, then my horizontal line hits the graph twice and I would not have an inverse. So what I have to do in order for sine to have an inverse is I have to restrict the part of the graph that I'm looking at. Okay, so I know that if I cross right here, I'm good, but as soon as I cross on this side, that's what makes me fail. So I'm going to cut my graph off right here. The value that I cut this off at is at pi over 2. Okay, so this part of the graph is no longer going to exist for the inverse. Now, if I go to this side, you'll notice that I have the same problem going on down here. If I draw a horizontal line, I'm going to hit twice. So again, this part's okay. It's this part that's the problem. So I'm going to cut my graph off right here. This x-axis value, that I cut at is negative pi over 2. So now this part of the graph no longer exists. So if I'm talking about sine of x, and I want sine of x to actually have an inverse, I have to restrict the domain. I have to make the domain only certain values between negative pi over 2 and pi over 2. We did this when we talked about x squared and the square root of x as well. Okay, so now if I go down here and I write my domain of sine, okay, is going to be from negative pi over 2 to pi over 2. Okay, and then my range is my y values. Well, the smallest y value that I have is -1. The biggest y value I have is +1. So this is going to be -1 to 1. All right, now we know that when we're talking about an inverse function, x and y switch, and that's related to anything to x and y. So the domain of sine of x is now going to become the range of sine inverse of x. And the range of sine of x is going to become the domain of sine inverse. Okay, so when we're talking about inverse sine, our values, our y values, can only be between negative pi over 2 and pi over 2. This is very important. Okay, so now let's talk about cosine as well. So we're going to graph cosine, again, thinking about on our unit circle, cosine is our x values. Okay, so when I'm at 0 here, the x value is 1, so cosine starts at 1. I just remember cosine starts high, meaning at the max, okay, or whatever the high point of the y-axis is. And then as I go to pi over 2, cosine there is 0, okay, my x value would be 0. At pi, I'm at -1. 3 pi over 2, I'm at 0. 2 pi, I'm back at 1, okay? And again, we're going to continue this pattern in the opposite direction from here to here so that I create 2 periods of cosine. Okay, so now, again, I have to think about this like I did with sine. If I were to draw a horizontal line through this graph, it's going to fail, okay? Meaning it's not invertible. So what I have to do is I have to restrict the domain to make it invertible. Okay, so for cosine, if I look at this part of my graph, this point right here is where I'm okay. This is the part where I fail. So this is where I'm going to cut off my function, okay, at 0. So this part of my graph is no longer going to exist. And now if I go in this direction, you'll notice that I'm going to fail again down here. So this part we'll consider to be okay. This is the part where I'm going to fail. So I'm going to cut my graph right here. This part's not going to exist anymore, and I just cut off at pi. Okay, so now if I'm talking about the domain of cosine in terms of this portion of the graph that is going to have an inverse, the domain is going to be from 0 to pi. My range is still going to be from -1 to 1. Okay, and then again for cosine inverse, these values are going to switch. So my range is going to become 0 to pi. My domain is going to become -1 to 1. All right, and then we're going to do the same thing for tangent. Okay, so again, if you remember from the tangent video that I had you watch last week, tangent, we're thinking about the slope of the line, okay, at each of these values. So when I'm at 0, the slope of that line is 0. When I'm at pi over 2, the slope of that line is undefined, so that's where my asymptote lies. When I'm at pi, the slope of my line is 0. When I'm at 3 pi over 2, the slope of my line is undefined again. And then when I'm back at 2 pi, I'm back at 0. So remember that within each of these asymptotes is a cubic curve that's going to look something like this. Okay, so this would be that part right there. And then I can do the same thing over here. I'm going to have an asymptote at negative pi over 2. So here's my cubic. This is going to be 0. I'm going to have an asymptote at negative 3 pi over 2. Here's my cubic. And then this part is going to be just the top half of that. Okay, so this is what the graph of tangent would be like. Now, obviously, I have these asymptotes here, which kind of tells me where tangent inverse would have to exist, because if I go and look at just this cubic curve, this all passes the horizontal line test, right? As soon as I move beyond this asymptote, then that's where I'm going to hit more than once. So this one's actually pretty self-explanatory. Tangent inverse can only exist between those two values. And this is pi over 2, because that's where tangent is undefined. And this is negative pi over 2, because that's where tangent is undefined. So my domain, is negative pi over 2, comma, pi over 2. And then my range is actually from negative infinity to positive infinity. So remember that these curves go up and down infinitely. Okay, so my range is a little bit different here. So now for tangent inverse of x, my domain is going to be negative infinity to positive infinity, but my range has to be between negative pi over 2 and pi over 2.